Certain material conditions could require a calibration of the computer to ensure the application rate set point is equal to the actual application on the ground. It is important to understand that the aggregate is being calibrated and not the memory. For example, if 3/8" chips are saved in memory 1 with an application rate set point of 20 pounds per square yard, and also in memory 2 with an application rate of 8 pounds per square yard, a calibration of 3/8 chips will update both memory locations. The memory functions serve as a means to quickly change between frequently used operating parameters. If the set point on the display is dramatically different from the application on the ground, it's possible the incorrect aggregate has been selected. Assuming this is not the case, the following procedure should be used to calibrate the aggregate to correct the application rate information stored in the computer. The aggregate to be calibrated needs to be selected on the display. Set the application rate set point to the desired value. The speed set point should be set around 300 feet per minute. Using the canvas supplied, place on a flat surface, leaving plenty of room for the ChipSpreader to get up to speed. With the control handle in the full forward position to assure constant speed, drive the ChipSpreader towards the canvas. Actuate the gate thumb switch about 10 feet before the material will hit the canvas to ensure the gate is in the correct position. Weigh the material and the canvas with the scale provided. Empty the canvas and weigh it empty. Subtract the empty canvas weight from the total weight to arrive at the pounds per square yard. On a variable hopper machine, this will need to be done for the left and right hopper. Do this a minimum of 3 times and average the values before making any changes. Compare the measured values against the application rate set point on the display to determine the calibration required for each hopper. As an example, assume the left hopper weighed in at 23.5 pounds and the right hopper weighed in at 18 pounds. Back at the control console, press the cal switch up or down to access the calibration screens. The first screen displayed is the right hopper calibration screen. The right hopper measured 18 pounds and the set point is 20 pounds, meaning the right hopper is 2 pounds light. Press and hold the cal switch up until the pounds per square yard reads 2.0. The right cal value will decrease as the rate is increased and increase as the rate is decreased. The right cal value is a density factor that serves as a reference to keep track of the calibration. Press the Save push button to store the calibration for the right hopper. This process will increase the output of the right hopper by 2 pounds, making the output equal to the application rate set point. The screen will reset to 0 once the Save push button is activated. Press the scroll switch down to access the calibration screen for the left hopper. The left hopper weighed 23.5 pounds at the application rate set point of 20 pounds. The measured weight is 3.5 pounds heavy compared to the set point. Press and hold the cal switch down until the pounds per square yard reads -3.5. The left cal value will decrease as the rate is increased and increase as the rate is decreased. The left cal value is a density factor that serves as a reference to keep track of the calibration. Press the Save push button to store the calibration for the left hopper. This process will decrease the output of the left hopper by 3.5 pounds, making the output equal to the application rate set point. The screen will reset to 0 once the push button is activated. The calibration for the left and right hoppers is now complete. To exit the calibration screens, press the scroll switch up 2 times to return to the main operator's screen. The calibration screens can be exited at any time by pressing the scroll switch without changing the calibration. The calibration is changed only by pressing the Save push button.